Assalamu alaikum wa rahmatullahi wa barakatuh. We return back to the second video of this section which talked about circular permutation. Circular permutation. What is the meaning of circular permutation? Suppose you have a table and your family is coming, but it is not a square table or not a rectangular table where you will put, or maybe it is a circular table where you will put the biggest family, or your dad or your father or grandfather. Like what we have, you have, suppose, like this. Suppose you have a circular table like this. We consider the biggest one in your family is sitting here. Then you will start to count from his right or from his left. This is why when you calculate it for a circular permutation, you will have n minus 1 factorial. Why minus 1? Since you have taken one person which is sitting and make him as a center of a circle, or at center of the table. You cannot use this formula until in the question set for you it is a circular table. Permutation that occur when objects are arranged in a circle are called circular permutation. Circular permutation. Then here circular permutation are not considered different if corresponding objects in the two arrangements have the same object to their left and to their right. Means if you have suppose one that he is in the middle of the circular table, you can count from the right or from the left. For example, if 4 persons are playing bridge, we don't get a different permutation if everyone moves to the chair at his or her right. For example, here, how many circular permutation are there of 4 persons playing bridge? Bridge means circular table, and there is one who is sitting in the beginning of this table and has something that makes the playing is stopped, like a bottle or something. Here, since he said circular permutation, then 4 factorial, n minus 1 factorial means 4 minus 1, which is 3 factorial, means 3 by 2 by 1, which is 6. The theorem. The number of permutations of indistinct objects arranged in a circle is n minus 1 factorial. Notice permutation, all the previous theorem or theorem 1.4, theorem 1.35, the order is very important. Order is Very, very important. Important. Which means you cannot use permutation only if the order is important. Otherwise, we will use another thing which is called combination. How many different permutations are there of the letters in the word book? Notice the word book. First letter, second letter, but you have B. Here, B, one letter, letter B. O, two letters. K, one letter. K, one letter. You have repetition. You have repetition on letter O. Then you have here 4 factorial over 2 factorial. Here you have B. You have here one repetition in one letter. How many permutations? Here we will have 4 factorial, since we have 4 letter, which is 24. But we have 2 letters, which are one repetition in one letter, which is O1, O2. This is why we said 24 over 2, which is 12. We can solve it by another way, but until we move to the next theorem. This is why we will use the other theorem. Here, example 1.12 will be omitted. Here, theorem 1.6, which is very important. Very important. The number of permutations of n objects of which n1 are of one kind, n2 are of one to second kind, nk are of kth kind, and you have an important condition, which is n1 plus n2 plus n3 up to nk equal n will be this formula. N factorial over n1 factorial, n2 factorial up to nk factorial. Here, in how many ways can 2 paintings by Mont, 3 painting by Ronier, and 2 painting by Degas be hung side by side on a museum wall if we don't distinguish between the painting by the same artist? Here, notice that we have 2 by Mont, 3 by Reno, which means 5, and 2, 7 by Degas. In how many ways? We have n equal 7. n1 plus n2 plus n3 total will be also 7. Then we will use n factorial over n1 factorial, n2 factorial, n3 factorial. This why we will have 7 factorial over 2 factorial multiplied by 3 factorial multiplied by 2 factorial, which is 210. Notice that we need here order is important. Before we will return to or go to combination tawafiq, I will go to solve some question before we move to other part, which is combination. Here, question number 13. here solution 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 question number 37. In how many ways can 5 persons line up to get on a bus? Here you will have what? These questions, I will say to you that they are from page 25. I choose some questions that are examples. You don't need to solve another questions. I will solve with you all these questions. Page 25. He needs in how many ways? Number of ways. I will solve it downstairs. Solution. Solution of number 37, page 25. In how many ways? In how many ways can 5 persons line up to get on a bus? 5 persons, then it means that you will have number of ways. Number of ways equal in factorial, which is 5 factorial, which means 5 by 4 by 3 by 2 by 1, which is 120 20 ways. This is question number 37. Question number 38. In how many ways can 8 persons form a circle from a folk dance? 38. Page 25. Circular number of ways equal n minus 1 factorial, which is 8 minus 1 factorial, which is 7 factorial ways. Now we will stop here until and I will return to you after that in order to continue the remaining questions and continue discussing combination. Thank you very much for your listening.